Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific time, 12 midnight Eastern time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California.
Yep. Help us welcome Sadie Coffin. We'll be back in 8.3 seconds. Sadie Coffin is a fourth-year PhD student at the Rochester Institute of Technology, studying galaxy evolution through participatory science. She leads Redshift Wrangler, a citizen science project that engages volunteers in analyzing galaxy spectra to measure redshifts and uncover the properties of and behaviors of distant galaxies.
Real quick, hi Janie, thanks for joining us. Happy Friday to you too. And welcome, Sadie Coffin. Excellent. With a passion for inclusivity in science, Sadie is dedicated to making scientific research accessible to everyone. Yay! Her background includes work in science communication, public outreach, and fostering diverse communities in STEM. We got one more comment. I'll do that real quick. And
hey,
then
Dawn.
You got it. Good. Yeah. Awesome. Thanks for being here, Dawn. Okay, Sadie, give us a quick overview of you and how you got into all of this.
Hello, thanks for having me on your show. I'm excited to come join Everyday Spacer after I saw you guys feature Redshift Wrangler a couple times. You gave a great introduction already. I'm a PhD student in Rochester right now, so I'm a couple hours ahead of you all. And I've been here for 4 years working on galaxy evolution research in a research group here at Rochester Institute of Technology. And pretty much that entire time I've been working on this citizen science project called Redshift Wrangler. So excited to talk about it more with you all and chat about grad school. Yeah, it's great to be here.
Awesome. So yeah, I mean, how did you find out about this? Get to, I mean, we were talking before too, and it's your PhD project, right? Yeah, go ahead and put Scott up. Hey Scott, welcome. We missed you last week.
Definitely, yeah. So I started working on Redshift Wrangler when I first came to RIT, and it was a project that we were just starting to build and put together at the time. So we study galaxy evolution in my research group. So we're looking at galaxies in the distant universe. How do they form and evolve and turn into the galaxies that we see today, like our own? And one of the things that we want to know about galaxies is how far away they are, what the distance is to these galaxies. So one of the ways that we do that is by looking at the light from galaxies. And a big part of the study of galaxy evolution is spectroscopy. So this project is one way that people in my research group study spectroscopy, study the light from galaxies. And the last 4 years, we've been putting together Redshift Wrangler, the project, building on the platform Zooniverse. We launched it to the public about 1.5 years ago on Zooniverse, and then since then, we started looking at our analysis, and we've started to make calculations and see what we can learn about these galaxies. But the goal is to have it ongoing for a long time in the future. So we pretty much want to maintain Redshift Wrangler as long as we have data that we're interested in finding out more about, that we want to, as long as we want to look at galaxies in the distant universe and find their distances, we'll keep going with Redshift Wrangler.
Oh, good, because in a couple of times, we've seen a project 1 week, then by the time it gets to the show, it's at 100%. And it's like, scramble.
Now what?
But,
yeah.
So has the process or the data changed a lot or a little since we did our review of it?
So in the last couple of years, I think when you were first looking at the data, we were on our first data set. When we first launched the project Redshift Wrangler, one of our motivations is that we have a lot of existing galaxy spectroscopy. We have a lot of existing data of galaxies in archives that we want to make measurements of and make a catalog of their distances and their redshifts. So we started out with a data set for which we actually know the measurements already. And once we calculate them with Redshift Wrangler, it's kind of a test run to see how well we're doing, how close are we getting to our our accepted catalog values, our expert values. So with that first data set, we're starting now to look at how does that compare with our catalog values? What do we need to change about our progress going forward? How can we improve our citizen science? And since then, we've gone through 2 other data sets. We've gone through data sets from the Keck telescope, the Gemini Observatory, the Subaru telescope, and we've got another one that we're preparing right now. But every time we finish a data set, we have a new one that's in the works, and we're kind of trying out a new method of taking a little bit of a break between them. So right now, if you go into the site, you'll see that there is an active workflow, and we're working back through our first data set to add more classifications to it. But we have new data that's being prepared and is coming in soon. And we're thinking about keeping a task active on the site that is almost like a practice task. We've gotten a lot of feedback, and I think a lot of citizen science projects get the feedback that it's difficult to know how you're doing when you're going about a task on your own. And
Yes.
there's a lot of desire to know if you're doing the right thing, if you're making the right classifications.
Yeah.
Mm-hmm.
Yeah,
And
we've
it's-
noticed that too when we're doing like the demo, and it's like,
Right.
hard to
Totally.
tell here.
I think it's hard on both ends, because when I'm a citizen scientist myself, if I'm working on a project, I really want to get feedback, know if I'm doing it correctly. I don't know if everyone here is going to know what citizen science is right off the bat, but essentially, because we're training volunteers and we're asking people to make classifications on our data, we want to leave a certain amount of give, so that people who are learning our data and working on the project make their own decisions and classifications. It kind of defeats the purpose of our project if we have a bunch of people making the exact same analyses of an object as us. That I think the real advantage of citizen science is that we're getting a lot of diverse perspectives. We're getting people looking at the data with different eyes than me, than anyone who's put the data together but might not see things that we aren't looking for.
Right.
So it's difficult to balance, because I both want to give people reassurance that you are doing the right thing and you're making the right classifications, you're on the right track. But I don't want to encourage people to that there's a right or a wrong answer, because I could be wrong too. If I think there's an emission line here, you could easily argue with me that there's not, and I'd be willing to hear it out. So there's a danger to too much feedback if we're training people to make the exact same classifications as us and having I may as well make 100 classifications on each object myself. But it's really hard to dive into a subject material that you are not an expert in, that you haven't done before, and to not, get that feedback that we're really used to growing up in school of correct answer, that's the wrong answer, or here's what you need to work on more.
Yeah. Does this project, I forget, does this one train an AI to seek out these? Because sometimes they do, and it's like, okay, that's kind of interesting.
Yeah, I'd say not directly on this project, Redshift Wrangler, but that's kind of an alternate method of doing asking some of the questions that we're asking, doing some of the research that we're looking at. That citizen science is one method that we're using to calculate redshifts, that here we're looking for specific measurements of these galaxies. And there are other ways we can do that. We've done that in other ways with other data sets, or even some of these data sets. But there's often not just one way to do it, that we want our citizen science methods to complement machine learning and automated methods. But also with a lot of the data that we're looking at, machine learning and automated methods don't work great with data that is really noisy, doesn't have very high signal to noise. Stuff like this, at the current moment at least, I think benefits from having more human eyes on it. So there is a big benefit to having citizen science run through our data now, and that what we're doing now might train automated methods for the future. But that's not directly a part of what Redshift Wrangler is currently
We got
doing.
a bunch of comments, and I think it's one of them is from somebody who knows you. So Scott, he says, "Oh yeah, I know about counting 1,000,000 rocks in one picture of Bennu. So I appreciate the feedback on a training session on a citizen science project."
Love
right
that.
on. Oops, let's see. Is this do you know this person? We have a system in place that helps us monitor if one person has a completely different measurement than others on the same object, and we can go in and give it a look. So, and we say this too. It's like I have a feeling, and some of them actually say that there's like a dozen people looking at this, and one project had like 100 people. So I think the thing is, you're looking for a general consensus, and then you'll say, okay, that's probably right. This classification is probably right. But if there's a lot of varying things, then the folks that are studying this, like you, can go in and say, okay, what's really going on here? We've had too many different ideas.
Absolutely, yes. Yeah, great reminder from a fellow Redshift Wrangler.
Welcome, Simply TV.
That, yeah, we're looking at an average response. So we're also getting between 10 and 20, now closer to 20 responses on each classifications on each object. So on any one spectrum, you know, it's maybe easier to go about it knowing that your one classification won't overly influence our results, that when we average it out, and I can even show a photo of what that process looks like, but any one classification that is way off of others doesn't end up coming into our calculations anyways. So
yeah, like she said, don't worry about messing up too much. Did you want to share your slides? Is that what's
yeah, totally. Okay, let's see if I can find this slide where
let me know when you're ready. I'll put it on the screen. There?
So this one, yes.
Okay.
This is a little bit zoomed out, but I think I've got it highlighted here. This is an example of what our data looks like. So anyone who's done Redshift Wrangler before, maybe this looks familiar. Let's go back to the full image for a second. If you haven't done Redshift Wrangler before, it might look kind of intimidating, but this is our spectra data. So this is looking at the energy, energy from a galaxy, is looking at the light over different wavelengths. And what we're looking for is the features here that stick out apart from the noise. And this is showing that the red boxes are all of the boxes that volunteers have drawn on the project. We've asked volunteers to box each of these lines when you see it in the data. And this tiny blue, if you can see the blue rectangle overlaid there.
Yeah.
The average classification. So that's once we've taken an average of the locations of all of the boxes drawn by volunteers, we're going to end up using that in our calculations and analysis rather than any one person's markings.
Interesting. Okay. Oh, if you wanted to share some more, I kind of oopsed. So if we want to go back to the slide, let me know.
No problem.
Okay.
So have there been anything that the citizen scientists noticed in there that was a surprise to you? Like some classifications that they gave that were a surprise?
Great question.
That's a great question. I'd say at least for the first data set that we're looking at closely right now, since the first data set is the one that we have easy comparisons for, we can look at maybe not the right answer, but what the catalog says, the expert answer kind of. And for the first data set, there's a lot of agreement between what we expect and what we've calculated with citizen scientists. So it looks really promising for being able to use this method on other data sets. So far, what we really need to find is to have multiple objects, multiple lines in each object, that is. So if we have just one feature in an object, it doesn't help us identify a pattern of lines, which can actually figure out which line is which, and then figure out what our redshift value is. So in order to make the calculations, we need to find more than one line. And the objects that don't find more than one line, we're using a less reliable method. We're going off of the photometric redshift, which is a less precise measurement of redshift. So one of the things that we're working on improving is adding more classifications to try and increase the lines that people have found. So I'd say we were really impressed with how accurate the method is for objects with multiple lines, that when there's a really clear object like the one we were just looking at, multiple lines, we can easily find the redshift that agrees with our previous calculations. But when there's only one line, it gets trickier. The fun things that we've been finding that we didn't expect as much are that when people are posting on the talk boards, we have a feature on Zooniverse where when you're looking at each galaxy, when you make your classification, you can add comments to it. And all of those comments go then to our researchers, our research team, our moderator, and we look through those and reply to them. And if they're marked with a certain tag, we can pull those out too and say, okay, someone's marked this one as a star. Someone's marked this object as a really noisy spectrum. Someone's marked this one as a good example. And through that method, we found a lot of objects that have serendipitous spectra. So that's where you have two galaxies that have both been captured in the spectrum, and only one is being shown in the 1D, the spectrum at the top, the graph, and then the picture of light at the bottom, the 2D spectrum, will show both objects. So we've had a lot of people have fun pointing out serendipitous spectra that, hey, there's two galaxies in this image. I think there's an extra spectrum we could pick up.
Bonus
galaxy. Yeah, so that's the fun feature of doing stuff like this, is that the people who are doing these measurements for us aren't just data machines. We might do a different method if we just wanted machines to make our data analysis more efficient. But the big advantages to using citizen science is that humans are coming with a lot more than just a machine, is that they're finding things like serendipitous objects. They have different perspectives. They think things are cool and will point them out to us, and we can start a discussion. There's a lot more that human motivation brings to the table, I think, that can sometimes be seen as hurdles, but are really advantages in citizen science, that in no part of science is are humans separated from the science. Science is being done by humans. So I think that that's a really kind of cool thing that is really evident in citizen science that we can forget about sometimes in other practices, that science is not just a cold, hard truth or, some kind of a rigorous pursuit that we should separate from our own bias. That, inevitably there is a human bias in collecting and interpreting data. And it's cool to be able to use that.
Got it. So, and I know we were talking yesterday and you had sort of this concern, is it like too technical, or, and I think, and certainly ask the audience if you like, I think that you're going to find, people that like a really simple thing, or people that like a really, sink your teeth into a thing. Like I'm kind of that way. I like to really like, oh, this, and I'll say that too when we're doing our demos. It's like, oh, this is really cool. And you can learn a lot of stuff and sink your teeth into it. And sometimes like, you might want to have a degree in this to do it.
Well, and that's where with your field guide, there's a lot of field guide, which in a lot of ways, it's really, really good because, you've got it nicely broken up into a lot of different subjects instead of just like, here's this one section that's 4 pages long, and so that's for the people who want to either just gloss over it or who want to deep dive. I mean, I'm an RTFM guy. Read the manual.
Are you? Okay.
So go through it all and just get all of it, and then go through it after I've done a couple of classifications, because then it's, wait a minute, I saw this somewhere.
Yeah. Well, to me, it's an experience thing. So now I can go back and say, okay, what did I miss from the first go through? And anyway, yeah, go ahead and like I say, you want to ask the people. Absolutely.
Yeah. I love hearing about even how the two of you approach citizen science projects differently. I always am interested in asking people. I think I'm always really interested in what draws people to a citizen science project, because there's something different in it for each one of us. And motivations are very different. That I've seen some studies about citizen scientist motivations, but I'm always really interested to hear what brings people to a project and what you're interested in a project. And on the flip side, what are the barriers that turn you as an individual away from a project? That what are the things that you encounter if you were looking at Redshift Wrangler for the first time right now, which maybe some people here have. I'm curious what people's first impressions are, because I might hear from the really enthusiastic volunteers later, and we get to chat with them a lot, and I can hear their feedback and opinions. But I always find it really intriguing that I never get to hear from the people who don't have access in the first place. If there's something that's preventing someone from feeling included on the project or welcome to the project, or if someone doesn't understand the project or have access to the project, that's not always a perspective that I get to hear from my side. You have to kind of go and seek it out. So I'm so curious to hear from people who have tried the project and who haven't, what would bring you to a citizen science project, what you're looking for, what keeps you on a project.
Brilliant.
Varying levels of experience with citizen science, but it's such an interesting question I always think about.
Very cool. So if anyone here, we encourage you to leave some feedback for Sadie, and you can, if you put your comment here, we'll share it with everybody. But yeah, oops, had a thought and it's gone. Anything for you?
Well, I got started with citizen science projects since
long time ago.
Yeah.
Well, because Galaxy Zoo, wasn't
Galaxy
it?
Zoo,
Yeah.
before Zooniverse
I didn't even know about that.
gobbled it up.
Gobbled it.
And then there was counting craters on Mars.
Oh, that's so cool.
Both of which were fairly simple, basically graspable things. And that's what this is. Some of the things on there are not as easily graspable.
Yeah.
And that's what I like. You have a fairly, I don't like to use the word simple, but yeah, it's a very simple thing that the person has to do.
It's eminently doable is the way I think about it.
Yeah. So it's simple. It's figure this out, draw a box. Some of them are, what shape of pretend fish is this? What? For one thing, take this to an art crowd, but
that'd be okay.
Yeah, I've seen some of those like that.
Yeah, and I really like the one with the women from 100 years ago who actually wrote in their notebooks, and you point out the things from the notebooks. I was like, because of course being, and you
love that one too.
Yeah, isn't that great? You might feel this way too, because there's not, typically hasn't been a lot of women in technical areas. I think that's changing, and I'm really glad. I mean, our meetups have about half and half, which is wonderful. But yeah, one of the things we were wondering too, and we can get that in a minute. But what's your experience as a woman? I saw you put your slide together. Do you want me to share that?
Oh yeah, sure. So this is, I'll now arrive to the other topic in a minute, but following off of what Jeff was saying, that I love how you walked through the field guide and the tutorial in your exploration, because I think a lot of the field guide that we got, the feedback that we got early on in the project was, I think originally I was putting together a really lengthy tutorial, a really heavy walk through all the information, almost in like a mandatory walkthrough, and then a little bit of extra was in the field guide. And based on the feedback, it felt like it was a lot more user-friendly to have a short tutorial. So the people who wanted to just dive in and try it just got a brief, here's what you're about to do, just go in and try it. Yep. And the people who wanted to read the whole manual, that also exists, but you're not being kind of walked through it originally. You get to go explore the information you want to. If you want to learn more about certain types of features, or another walkthrough of the task 1 or task 2. So we reorganized a lot of our information on the site to try and think about how you could have different experiences, and how we could represent information in different ways. That's been something I've thought about a lot. This is an image that I created for the background page of the website, so you can also find this on the Redshift Wrangler website. But this is kind of as simple as I could make the entire process of where Redshift Wrangler fits into our research, essentially. That we're studying galaxies in the distant universe, so we're taking observations with our telescopes, we're pointing them at the galaxies, splitting up the light to look at the spectra is what we're interested in. And then the citizen scientists, that's where the measurements come in on the spectra. We're going to mark these features, and then we take those markings and we use that to analyze the results, calculate redshifts. And from there, we can learn so much about the spectra of a galaxy that there's kind of endless future projects possible with the outcomes of Redshift Wrangler. Maybe there's some initial goals that we want to create a catalog with all of these measurements in it. We want to make this information more accessible. But long term, most of the things that we study about distant galaxies really require us to know how far away they are. Like kind of our goal, maybe I'll even move a couple slides to this timeline, which shows us what we're really looking for, that we want to look at the spectra of distant galaxies, and in order to really know what we're looking at, we need to know how old the universe was when the light was emitted. So on the horizontal axis here, you see the redshift, this measure of distance essentially. And what this is telling us is that we need to know where the galaxy lives on this timeline. We really need to know how old the universe was when the light was emitted, how long ago was the light emitted from the galaxy, how far has it traveled to reach us, how much has the universe expanded. If we can locate the galaxy on this timeline, that kind of allows us to know what kind of a galaxy we're looking at. That we can't compare the galaxies to each other if we don't know where they live, how old they are, how what stage of their evolution they're in. So yeah, really tangent.
Yeah, it sounds like it'd be really interesting to find, if they exist, a really complex evolved galaxy really early, because then it's like,
well,
how'd that happen?
And some of them have been sort of like, that's fascinating because they're very much similar in a lot of ways to kind of current mature galaxies, which I think some of the people found surprising. We watched some of the shows out there. Maybe you've heard of Anton Petrov. He's really good.
Check him out.
Yeah, Anton. Yeah, he's really good. A bunch of the people here. In fact, I think Dawn told us about Anton. Or did we find him and then she talked about it? I forget, but he's got some really good stuff. And I think he does something almost every single day. So lots of science out there.
Yeah, I think those are kind of some of the most exciting things, is when we discover things that are further along in their evolution than they should be early on. That, you know, a lot of the discoveries we've been making recently, especially with, you know, new, bigger and better instruments coming out, with JWST telescope that I'm wearing.
Oh, that's what that is. Okay.
It's the mirror right here. Yeah. We're learning so many things that we didn't think could be possible. It's kind of the cool part about research. You know, there's always more questions being asked rather than really finding the answers. There's always new things to learn about the universe. So
absolutely,
there's still so much that we don't understand. There's still so much to learn about the early universe. But it's fun to be part of it. And to cycle back to your question from before, I'm also so curious about your experience as a woman working in science, Pam. And I know you mentioned having a big community of women in your meetups and all of that. But I'm so curious about the experience of women in math and science always, that I feel like I run into a lot of different perspectives of people in STEM fields. And I think, I don't know, personally, I had an overall really positive experience in math and science, but I don't know, it's not without a lot of lack of representation. That I haven't always seen a lot of people that looked like me that I thought I could see myself in. And so having like a few mentors throughout my science career has been the thing that made me keep wanting to do science. Is
cool.
Having someone that I felt like, oh, I really can't see myself doing what this advisor or this colleague or peer is doing. That's kind of, I think if I hadn't had that, I wouldn't have been able to keep doing physics and be interested in studying the universe. But yeah, I've thought about a lot in the world of citizen science too. So I like that you brought that up, because I feel like, especially in the citizen science field or community, there's definitely another demographic then, where the kinds of people who are able to participate in science projects, who both have access to these projects and have time and means and encouragement, are often, it can be a really limited population. That, you know, in a lot of these statistics that I've seen, there's a lot more male, white, educated, older participants in citizen science. And so it's hard to always know the exact demographics, because I think one of the cool things about citizen science is that you can kind of, at least on a project like on the Zooniverse platform, you can jump in without providing a lot of background information. You can kind of participate without even having an account. You can just try it out and then leave the next day. But yeah, it's definitely something that I think about a lot, because, you know, it's related to the idea of representation and visibility, that the same way that I may not have kept doing science if I hadn't seen people who were as excited as I was and encouraging me and looked like they were doing something I could see myself doing too, then I wouldn't have stuck around in it. So I think it's a big next step in citizen science to keep, getting better at seeing the people doing the science, not just seeing the project standing in front of you, feeling welcomed in individually. So yeah, I'm really interested in hearing about your experience too.
Cliff is here. Cliff is in Australia. Thanks for joining us, Cliff. Sorry you had no internet. That sounds a little rough. Glad you're here, though. And you can certainly see the replay. So, and I was kind of curious, too, is this something you've been involved with for, like, your whole life? Because for me, I didn't really know I was kind of into science that much early on. And my math teachers, like in high school and stuff, certainly weren't very good. But I did go, and I got curious about a couple things. Oh, gosh, I must have been about 20. And it was we got water on the mirror in the bathroom, and with a metal frame, I got a shock. I was like, well, how did that happen? And then I wanted to fix a light fixture in my ceiling in that same apartment, actually. And that sort of put me on the path of, I would like to really know this. And so I went to school for it. I have a 2-year degree in electronics. I was trained to design computers. But that kind of like set me on the path, and, then finding out who I am and what I like with a couple of books when you're 20s, you don't really know a lot of that stuff. And so a lot of people don't. And then you sort of either work into it or, like me, do what I call basic research, like 600 hours of figuring that out. Oh, and Scott has a comment too. We definitely need to do a better job of encouraging female scientists in general. Thanks for that, Scott. Really appreciate that. I think that women have a little bit different perspective, and it could be very valuable wherever we may be. But yeah, so I didn't really start that way, but I kind of ended up really involved with science and interested in, and I love math now. I had a really good teacher in the technical school. So yeah, is this a long time thing for you, or is it kind of more recent, or?
Yeah, I love hearing about your path. I feel like I had a bit of a similar trajectory, that I wasn't, maybe I was a bit interested in math and science when I was younger, but I think I was interested in a lot of things, and I had a lot of favorite subjects. And I went to a liberal arts school in college. I kind of, throughout my education, probably have done a lot of different things that I've spent a long time being really interested in art or English or Chinese language or different science topics. And so I think I had really great physics teachers growing up that,
oh, cool.
I didn't always feel like I was a very good physics student or a very good math student. But I just do remember loving physics. I really wanted to know more about how the universe worked and why things were the way that they were. And so I went to a liberal arts school and thought, I kind of think I'm going down the route of physics. And I started feeling like I loved astronomy and learning more about the universe. But I still wanted to learn Chinese language and take art history classes and do sports. And so I spent my time doing a lot of different things and didn't quite focus down into the astronomy route until I came to grad school. Then I felt like, well, I've been interested in astronomy and astrophysics long enough. It's about time that I want to actually go and study this in a degree now. I want to study not just physics. I want to specifically know more about astronomy.
Nice.
In that way. So I think I may have kind of had that in the back of my mind for a while, but because I never really let go of that idea, then I felt pretty confident that it was what I wanted to do. And kind of throughout my college experience, I did a little bit of research in astronomy that was really fun. And I got to, after I graduated from college, I had a couple of years where I'm originally from the Washington, D.C. area. So I went back to the Washington, D.C. area, and that was the peak pandemic. So I was living there for a while, and I spent most of my time, I think, trying to keep up my interest in astronomy. And there's so much that goes on in DC. So I was doing, the Air and Space Museum has an astronomy education program. There's lots of public astronomy events and lots of library events and talks. And that was like so invigorating. It made me so confident all over again that I wanted to learn more about astrophysics in a formal classroom setting. So after I graduated college, I thought maybe it's not what I want to do. I'll think about it and make sure it's really the right thing for me. And it totally was. I kept thinking about how much I wanted to learn more, and I so loved like volunteering. I got to do research with someone remotely during the pandemic. That was such a great experience. It was so relieving, in that time when I just graduated and I didn't know what was next, and I was stuck at home, and was so lucky to find someone who took me on to come and do remote research and teach me how to look at X-ray data and measure supernova remnants. And I thought it was the coolest thing. It was so much fun.
That's neat. Who is that? Who did that for you, with you?
So that was so I was working with a astrophysicist called Dr. Brian Williams, who's at the NASA Goddard, the X-ray astrophysics lab.
Wow.
Almost quite sadly, I was about maybe 30 minutes, a half an hour or so from the NASA Goddard site where I was living at the time. Not once did I set foot on the actual campus. It was fully remote. We didn't quite go back in person before I stopped working for him and came to graduate school here. But it was fun. It was so nearby, and so it was going to work out great if I went back in person, and then it never did.
Aww.
But it was such a great experience. It was through that I connected with a lot of other people who worked at NASA Goddard, who were in their education and public outreach team, and who worked on different kinds of science communication. They had like a mentorship program where I was connected with a lot of different people with such different paths through astrophysics. So I met people who had a PhD in astrophysics, but had gone on to do science writing, science communication, and people who didn't have a degree in astrophysics at all and were also working on the same team, and who they're having that experience, and that perspective was so valuable. I think that made me really excited when I came to grad school. And in my incoming year, for example, we had about 10 people, and all of us had different experiences that we came from different types of degrees and backgrounds. And it's a lot of fun, I think, to be able to work with people who have such different perspectives and goals too, that not everyone who works with me wants to go on to do the same things. But having all those different perspectives then is so valuable in kind of getting to know the different sides of science and all the different roles that are important. So yeah,
I totally think that, somebody from a different perspective in the world and in life can contribute tremendously. I think there's a book I read. It's about collaboration, and they're talking about like even like older people or little kids. You can really kind of get some very different ideas from, well, anyone really.
Definitely. Yeah. One of my favorite things to do in science communication is to chat with kindergartners, actually.
Oh, neat.
My mom is a kindergarten teacher, and so I've often gone in to give them a planetarium show, a virtual planetarium show, and really they ask some of the best questions that anyone could ask.
Okay.
A great perspective.
Little kids say amazing things, don't they?
Yeah, they do.
And they ask the best questions too.
Yes,
well, they haven't learned what not to say.
Exactly.
They have that scientific curiosity and wonder, which I think is just what is ultimately my interest here. Is that I kind of don't have an answer to what's next after grad school. I just was so interested in being curious and thoughtful about science and research, and being able to come here and be part of asking the research questions that I think is kind of fun when you have the flexibility to just be open to whatever you discover. That I also really loved taking classes in my first couple of years, but it's a little bit different to then switch into doing research all the time, where you're making your own path through the field. You're not just trying to find the right answer to problems in a textbook. Yeah. So yeah, I'm really, really liking having my own project in Redshift Wrangler. That's kind of something I can keep working on making better, and using it to see how well we can make these measurements and things like that.
Well, and this is really cool for us too, because we've done a lot of these demos, but you're the very first person that we've had come on the show and talk to us about the project from your side of it. So thank you so much. We really appreciate being here. And we got some thoughts here about like the team and well, why is citizen science important, especially in fields like astronomy. So if you want to try and get into that a little bit, that'd be great.
Totally. I feel like I have a lot of thoughts about this, and I'm still really curious about things from the perspective of participants in citizen science. But at least from as far as I know, from the types of research we've done into citizen scientist demographics, I think that the motivations behind people in astronomy projects can tend to be different from other projects.
Oh.
If I participated in the past, I really like doing projects on Zooniverse. And, I've done some projects that, like you've mentioned, it's really fun to do, transcribing old documents, or, there's a lot of projects out there that are environmental projects. And I think those are really cool. And they're often, I don't know, maybe a slightly different audience that at least the experience of the majority of participants can be different. I think on like an environmental project, it's a little bit easier to see how it can impact your day-to-day life, or to feel like you want to be involved in something in your local community. And there's a lot of environmental concerns that people want to be a part of or help solve these days.
Right.
And I think it can be a lot harder to see how studying astronomy and astrophysics can impact us on a human level. And there's a lot of questions out there about, is it really worth putting money or attention or interest or funding into studying space, studying things far out in the universe, when we have so many problems closer to home to be solving? And it's definitely a valid question. And I always think there's many different possible answers, but there's so much to study in space. It's not one or the other in my perspective. And there's different kinds of barriers and different kinds of challenges to these projects. So from my experience, that it can be easy to think that for a project studying this sky, studying space, anyone can go outside and look up at the sky, and it's kind of open to whoever wants to look at the night sky, if you're maybe have access to dark sky. The same way that it might be easy to think that anyone has the same access to the outdoors, anyone can go and do the same kinds of projects in their local environment. But in both situations, it's not exactly true that not everyone does have the same access to our project looking at space, and not everyone has access to the same background knowledge about astronomy and astrophysics, but not everyone has the same access when it comes to even looking at our data, that it's a little bit more complex than an image. And there's pieces of our projects that we have to make sure that that's accessible to screen readers or to alternative explanations. And it's hard sometimes to turn graphical data into something that actually is represented in different formats that people can experience in different ways. So I think that the challenges are different, but there's similarities in that it's actually really hard in any project to make sure anyone can participate and anyone is welcome and has access. But the things that I've heard from astronomy projects, at least, is that people tend to be more motivated by curiosity rather than kind of a just, I want to fight for my local community motivation. So that can be an advantage and a disadvantage, that the types of people who feel welcome to pursue their own curiosity and simple desire to learn and passion for space is also a very specific demographic, that we tend to get people who have a lot of extra time on their hands and who aren't students and who tend to be older or tend to be male. So it's hard to, I always think it's hard to make any generalizations, but the things that I see on our project a lot is that the people who are really rewarding their own curiosity are not the only people who have a lot of curiosity and a desire to participate and a desire to learn. So I guess
Yeah, go ahead. Finish up.
I was like, I keep coming back to the hope to figure out what are those populations of people who have a desire to learn and a desire to come in and then get stopped at the door, because we're only getting the people who really have the availability to lean into their passions and all of that.
So we have a comment, and then I have a couple of thoughts for you. So Daniel, welcome. Glad you're here. Is there any way to correlate this work with data from muon detection kits?
Ooh, I don't know much about muon detection.
Me neither.
But it sounds super cool.
Yeah, maybe Daniel can come on the show and tell us about that. Daniel.
Yeah, I'd love to hear more about that, Daniel, actually.
Yeah, Daniel's actually lives like a couple blocks away from me. Oh, not quite. Okay, not quite the science we do. Okay, got it.
Yeah.
So maybe there's not an exact correlation. So a couple of thoughts I had while you were saying all that. There's a website, and it's a citizen science project, but it's not really associated with Zooniverse. Called Globe at Night, and it's very simple. About once a month, they have a 10-day span, and they want you to go outside, take a look at the sky, and report back on like if it's cloudy or if there's a certain amount of the stars that you can see, or if you can see, more or less, and they have little charts. So you can just kind of like hit the charts, like even on your phone, you can go out and kind of take a picture or look at the different charts and report back on that. And you can do that from anywhere in the world. They have a southern hemisphere target and a northern hemisphere target. Actually, this year they started giving you choices. So there's 2 in the south and 2 in the north most months now. But yeah, they're really hoping to find out like what the whole globe is like availability, especially I think for light pollution. Wasn't that light pollution?
Yeah.
And apparently this is a really important project. One of our guests was saying that this is really important. And the other thing I was thinking of too while you were saying that is, no matter what's happening in the world or your personal life, you have a constant in the sun. It'll rise every day, it'll set every day, and the moon, you can see it most of the month. It'll have different phases. You can rely on it. There's something you can rely on when it comes to the stars and the moon and the sun. And you've got some exciting things like comets. I guess there's one happening right now. You've got meteor showers. We've got that coming up. So, there's like this, maybe it's a spiritual component to it that I think could in fact help really anybody. You get to the point where you're like, just everything is crazy. Well, you can absolutely rely the sun is going to come up tomorrow.
Yeah.
So there's a lot of that in there that I think could be very helpful to pretty much anybody.
For sure. And I think that's such a fascinating motivation to pursue too, that, not every project will appeal to every person, but a lot of people can find different things that are interesting to them that I might not have thought is the main appeal in our project. So it's fun to be able to think about the different ways that we can advertise or talk about our project. So Redshift Wrangler, for example, I might imagine that people would be drawn to Redshift Wrangler who already know about spectroscopy or have a background in science or something like that. But that really would kind of narrow down our audience. And if we make it more of a learning experience and kind of open up the motivations that no matter why you're coming in, you can start from scratch and hopefully learn how to look at our data with no prior experience at all. I think that's the most fun thing there. And, maybe the example that I think of now is that I was at this, a citizen science event recently, and they were talking about data they've collected for, it was motivations for people who join amateur astronomy clubs. They were finding that there's a difference in the reasons that men and women join astronomy clubs, at least.
Interesting.
The data they were collecting looked like a lot of men were citing that their reasons were to pursue a passion in astronomy and to further the field and to kind of advance their own knowledge. And women were more likely to say that they wanted to learn something. They wanted to learn how to use this equipment or learn more about astronomy. And it was kind of like a very subtle difference in having like a growth mindset in this, the approach that if a project was set up geared towards someone who didn't know anything coming in and kind of encouraging you to come as a learning process instead of the emphasis being more on come and help us improve the field or come and help us advance science, like the slightly different approach and the slightly different tools and language maybe that were set up could actually bring in a very different audience. That it looked really different in clubs if they, opened things up to, hey, if you're here for a social experience too, that sometimes is a motivation of women, that women were less likely to come if they were the only woman at the astronomy club gathering, because it looked like from the data women were benefiting more from this camaraderie, from learning from other people, not a solitary learning experience, and from being encouraged to not come in knowing everything, and that you will make those connections here in that club. And so similarly in Citizen Science Project, I kind of think of how subtle the difference can be for the audiences that we might attract. That and as you were mentioning, I think people think often of science being so separate from spirituality or from religion or belief, or like socializing. There's so many things that we think of as that should be completely separate from science. But all these things can be motivations to bring people in. And in the times that I've volunteered in museums or done more museum education, you'll often get a lot of people coming to something like the Air and Space Museum who might have a religious beliefs that are drawing them to want to know more about the universe. And that's also a valid thing, bringing them into science. Or they might, people come in a lot with, what I'm looking for, with myths, with like false beliefs about the moon landing is fake, or they really want to know about aliens and things like that. And it's so easy to kind of scoff and be like, well, that's not science, or that's not the truth. That's not what's right here. But there's so many different ways to get into science that, when I hear things like that, it's in so many different avenues in the world, I hear people just being interested in how the world works and how did we get here and what happened before we were here and what will happen after. That it's all different ways of science and thinking about what our purpose is really here. So no, it would go against the purpose of citizen science to ever turn away someone who came in for a different reason than I did.
Yeah, when people ask about aliens, and when we get them, sometimes I just have to say I have no expertise in that area because I don't. I really don't. Totally. So yeah, but it definitely has enabled people to connect and maybe learn something else. Oh, we got a question. So, yeah, very good points. Very, very good points. And that's part of why we bring guests too. We want to hear from a lot of different people, as many different perspectives as we possibly can, to encourage people to get involved. You don't have to be, like we've had artists, you don't have to be a science-minded person. You can look at this from all kinds of different perspectives.
Yeah. In fact, one guy was a juggler and was showing juggling in 0G because he went up on
space juggler. Yeah.
That's awesome.
Oh. Yeah, he was very cool. He actually came back and talked to us about his science stuff too.
Yeah.
So he had kind of both going on.
I'm a big fan of art, so I always love the connections between art and science. I think there's so much there too. I feel like I love to get the response that I just thought of, is that a lot of people, if I mention astronomy or astrophysics, I'm really into astronomy, I'll often get people who are like, oh, astrology, I love astrology. You said astrology.
Totally.
It can be frustrating to some people, or it can be a lot if you get that often. But it's exciting, really. It's another way of looking at the universe, at different cosmic influences and balances and imbalances. I think they're all just different entrances into science that can easily become what I and many others have been told, that if you don't really do science the way it's meant to do, you don't belong in this field. It's so easy these days, I think, for people to be turned away from science and math very early on. I don't know if you've ever gotten responses like this, that if you mention you're interested in science or physics, I get so many people tell me, oh, that's so difficult, I could never do that, or I'm terrible at math, physics, or I had a bad experience with a math or physics teacher, or that's so hard.
That seems to be hard for people, but I guess the people we hang with are pretty into science, so we don't get that too often.
That's awesome too, because I feel like once you start to see people around you just rewarding curiosity, then it becomes easier to do it yourself. But yeah, I think these days I see a lot of younger children, especially, who at such a young age start to be told you can't do math.
Oh no.
Do physics, or you can't do science.
Oh no.
Well, I was fortunate. We were both of the age that when we were growing up, we had the moon landings.
Yeah.
And so,
kids.
So there was a huge interest in space. So it wasn't. So I think there's a generation of people who got into it because of that.
Oh, big inspiration. We got a couple comments, and I had another thought for you. A funny story, actually, with David Levy. All right, so Pam and Jeff did a show about 2 years ago called Cosmic Muon Images. That's a citizen. Yeah. That's one of the Zooniverse projects. Yeah. Kind of prompted my question. A lot of amateur radio people overlap with radio astronomy. Very cool. And also Daniel says Newton was a secret and ardent student of astrology. So my story, I'm at a conference. I think it was in Ohio at the time. And David Levy was there. He was a speaker, and a bunch of us were just having a meal. And he's like nearby, and I forget the exact question or impetus. Is I go, astronomy, astrology, whatever. Because it's really fun to tweak people like that. And he was like, so he'll probably remember me because of that.
And I mean,
and I don't mind how you come to it.
Astronomy was birthed from astrology.
Absolutely.
They needed to get better predictions of where planetary bodies would be.
Yep.
Mm-hmm.
So you have to hand it to astrology for that, because we wouldn't have astronomy. Tell
us about your team. I know you have a picture over there.
Yeah. Oh my gosh, totally. So maybe I've mentioned this previously, but we have a team of a lot of students at RIT who have mainly been putting together Redshift Wrangler. So I'm at the Rochester Institute of Technology in Rochester, New York, and I'm a graduate student here. And I started working on this project about my 4th year now. And when I first arrived at RIT in my first year, I started helping put together the project. It's in about a year and a half ago, almost a year and a half ago, we launched live to the public. So between those two times, when I first arrived at RIT, we were putting together the project. I was writing all the background information. We were getting feedback, beta testing our website, putting together all of our materials. And then once we launched, now I've started looking at the outputs from the website, the extractions from Zooniverse, and everyone on our team here helps with different pieces of that. So we mostly work with these students. We have undergraduates, graduates, postdocs, faculty at RIT who are part of the Redshift Wrangler team. But we also have people on our project who have been volunteers and have taken on other roles. So we had a volunteer has become our moderator on the website, and he helps us respond to comments on our talk boards. And he comes to I hold Zoom office hours once every month or 2 months. And we have had a volunteer who's getting to do even more work on our project and who comes and takes notes at all of our office hours and has assumed more roles as well. So our project kind of continues to expand. This is definitely not everyone working on Redshift Wrangler, but these are kind of some of the main students who have been helping put together the project, design the images that go into Redshift Wrangler, help put together the educational materials that we're going to use to promote the project, and then do the analysis on the other side of it. So the image that you're seeing here at the top is from our launch party, actually, too. And we had a workshop in May 2023, so about a year ago, when we launched the project, and we had an event in person in Rochester where we taught a bunch of people how to use it, and we celebrated it finally going live. And some of our team members were there in person at the time, so we have limited in-person photos of all of us.
So we caught it pretty early on, but of course we will go to the site and look for things like
what's new.
Yeah, what's new. We've kind of exhausted most of the physics or space ones, and then when we find them, we try and work it in somewhere. Okay, we've got a comment from Simply TV. I am a professional astrophysicist and my physicist, and my brother does astrology as a profession and is pretty successful. So my family agrees. Astronomy, astrology, whatever. I love it.
Exactly.
Thank you so much. All right. So anything else we want to know here? Kind of. Yeah. You keep talking about like how you create like educational materials, but like where do you talk about this? Where do you? You said stickers. I would like a sticker, by the way.
Yes. Absolutely.
Yeah, how do you get the word out? Or I mean, is Zooniverse the big platform to talk about it? I don't know.
Definitely. Yeah. So what you mentioned about how much our project has changed over the last couple years, we've mostly been cycling data through since our launch, but we've had a couple of breaks in between data sets. And we generally aim to have something on the website for people to work through at all times. But I keep the talk boards on Zooniverse pretty up to date, where we do have regular, not in person, but Zoom virtual meetups where I have office hours to chat with volunteers one-on-one. And I found that it's so helpful to just hear from people face-to-face about what keeps them going on Redshift Wrangler, what they want to see more from, all kinds of things like that. So those have been great. But we do also have social media. So the same kinds of announcements that I put out on Zooniverse, we share on social media, and I have an email newsletter. But I think that it's all kind of part of what you're expressing, that we want people to feel like they're part of an ongoing research project, that of course there will be people who will come in and do a couple classifications and leave, and that's also great.
Me.
Totally wonderful. We love having anyone come help us. But a lot of people, I think what gets them really excited about doing citizen science is being part of our team too. And that's on my slide. I've added that Redshift Wranglers are also part of our team. That I think I mentioned before, we're not just looking for data machines and people to just go through and make a bunch of classifications and then make perfect classifications and disappear. That we're looking for people to be excited about our research, and that's what's going to help them make better classifications, help them be more part of our research and take on more roles. There have been lots of successful citizen science projects like Galaxy Zoo, the one that launched Zooniverse, that have had lots of citizen scientist volunteers help author papers and get credited on their data releases and stuff like that. There's more to the role of a citizen scientist than just data collection, I guess, or just data measurement. That we want to really highlight things about our project and our motivations and who we are, to make people feel like they can know more than just what we are asking you to do. I want to be more of a trade-off, that there's things that we're kind of getting from both ends, by both teaching and training, and then letting you into our project, and then receiving help in return.
Some real recognition in some cases, and like the one said, "Oh, we might even name an asteroid after you." I was like, "Wow, that's a kind of a big deal especially for a regular person who's doing this." And we're very different. Like he's actually registered and done lots of stuff and lots of per project too. And me, I'll just go and piddle around a little bit, and if I like one, I'll do a little more, but mostly it's just been I've never registered. I've just done a few here and there, especially when I'm getting ready for a show, of course. But it's very different, and it's really nice to have that flexibility to be able to work it however you would like, and it all makes a contribution. So so wherever you're at out there, folks, feel free to participate however much or as little, or however far you'd like it to take you, you can get some real recognition, or you can do it in the background, just like me. So yeah,
that was how I feel like I first dove into citizen science, was during the early days of the pandemic, that I just wanted kind of something to do in the background that was interesting to me. And doing those kinds of projects, like doing transcriptions or looking at wildlife imagery and finding cool things in them, that it kind of made me feel like, oh, I'm being taught something new, I'm learning something new. And also at the same time, it's not for anyone else's benefit but mine. It's just because I decided to pursue this passion and have agency in my own learning. So now that I'm on the other side of it, leading this project, it was cool how it kind of worked out, that I started to hear about citizen science. And I was really excited about the idea when I was speaking to another citizen science project leader. There's a project called Aurorasaurus.
yep,
Aurora is such a cool project.
yes,
And the leader of that project I got to chat with during the pandemic. And she gave me so much advice and wisdom about citizen science, and was kind of steering me down the path of citizen science as a really useful way to practice science communication. And I coincidentally, when I came to Rochester, found this project that was just kind of getting up and running that they wanted to be part of. So I was really excited that kind of lined up for me right off the bat.
Very cool.
And I got to the other side and think of it as, all right, now I want to be that facilitator for people who just want to come in and be the agents of their own learning. We have the advantage of not teaching people in a classroom from a curriculum, in a strict, nothing against classroom environments, but there's more flexibility in, I like to think of being the facilitator for knowledge, and not, I don't want the relationship to be that there's a superior expert scientist here out of the grace of their heart imparting their knowledge on you, right? Like, we're all learning at the same time. There are plenty of volunteers on our website now who I say are more familiar with the data than I am, because they classify so many objects. And that their perspective is so useful now, because I don't sit looking through as many classifications as they do. So I don't always know the best ways to describe features to people, and they sometimes have even better ideas for how we can make that better, or use better explanations or language, or give better examples.
Cool.
So I love that. It's like we're all learning together. There's no real hierarchy in something like this. It's just that we're all facilitating each other's knowledge, maybe.
Yeah. And I've been reading it wrong. Simply 1V, I thought it was TV, old eyes, has made a couple of comments about you giving talks all over the world, and watched your presentation in Paris. Did you actually get to go to Paris? How cool is that?
Yeah, I did. That's
nice.
The benefits of being a graduate student in a big research group. That one of the best things about working on galaxy evolution at RIT is that we have a really big research group here, as I've probably already alluded to, of graduate students and postdocs and undergrads all working together to kind of answer different research questions around galaxies from different approaches. And a couple years ago, then I got to travel to Paris and give a presentation on Redshift Wrangler, which was about a year, I think, before the project launched. It was about a year before it launched. So at that point, I was presenting on the setup and the beta testing of our project, and what we were preparing for before the launch came up. And a year later, we have a yearly meeting with the collaboration of astronomers in this larger group. So the Cosmic Evolution Survey, COSMOS, is our larger collaboration that my advisor works in, Dr. Kartaltepe. And we met the following year, just before we launched the project. So kind of each year I've been able to follow up on, here's the progress we've made with this project. And this past summer, we had our meeting in Japan. So then we all went over there, and I got to update on, we're a year after launching now. Here's the progress we've made in our early results. So there's been a lot of cool things, I think, that we got to do as graduate students that I really appreciated learning about. That I get to do things that aren't necessarily always part of my direct PhD research, and it's cool sometimes to be part of other people's learning, to be able to go be part of the observing runs where we collect our data, to be able to go to conferences and talk about what I'm doing and tell other astronomers about it.
Would you please tell us about your necklace again? Janie Becker missed that part. Thanks, Janie, for asking.
Thanks for the question. I'm so happy to talk about my necklace. This is the JWST mirror in a necklace, and this is my lucky event necklace that I like to wear at astronomy events, or physics events, that when I've worn this at science or physics conferences, the astronomers will come find me and say, I think I recognize your necklace. Is that the mirror segment of the JWST telescope?
Nice.
It is. It's gold to look like the JWST mirror segment, which has these little
beryllium,
making it up. Yeah, is that gold color.
Yeah, and that's, we were lucky enough to be able to see the mirror when it was on the ground.
Yeah, I went twice.
Awesome.
You went twice too, right? Yeah, that was very cool. You got a couple other comments. Simply 1V says yes, and the Japan talk was a great update on how the launch went. And Daniel also writes, her necklace is the mirrors on JWST. That's JWST for James Webb Space Telescope. I have a funny story about that too. I went to their the one time, and the guy at the security desk was wearing one. I'm like, oh, that's cool. Where'd you get that? He's like, would you like it? And I'm like, oh, yes. And he just gave it to me. I'm like, wow.
That's
very cool. Yeah, it's a little pin, not a pendant, but. So, all right, Sadie, is there anything else you would like to talk to us about, encourage us on, or share? Take it over, and we got a couple other segments. We'll wrap it up after that, but please, one last thing you want to tell everybody.
I realized I must have skipped over a question, or maybe just a comment about the stickers that I was showing you earlier. That there's a bunch of different ways that I'm trying to kind of continue to hear from and chat with volunteers these days, and so we have kind of a regular newsletter. And most recently, I was sharing about new stickers that we've just got made. But we have a bunch of them I could show here, but I would love to share these with volunteers and Redshift Wrangler interested people that we've been making fun, colorful videos. This little character actually was designed by a graphic design student, undergraduate student at RIT here.
Cool.
And we had the coolest time giving her suggestions and asking her to make us a colorful rainbow lasso to put our character's hand. So we've just made all these stickers, and I would be happy to send them to people. In the update that I just shared, we were encouraging people to post an introduction on our website and make classifications, and I will send out stickers to anyone who does that. But we've in the past gotten some responses on a welcome and introductions page of introducing who you are. We have a get to know the Redshift Wrangler team page and different introductory posts. But all of our volunteers are also part of the project, and I think seeing other people be more engaged and participate like that can also help with the representation, visibility that I was talking about. That it's a really cool thing to be able to highlight stories and to hear where people are coming from and what brought them to the project sometimes. So our kind of hope was that people would write their own posts, introduce themselves, and put a face to the name, kind of, or at least just give a little backstory of what brought them to our project in exchange for a sticker. But we have so many of them. I would love to send them to all interested parties.
Very good. Thank you.
Reach out to me.
Yeah, you might want to put a link in here when we're done talking, because we'll do a couple more segments. Put a link in the chat about
reminds me.
Where's the best place for people to either,
I put one
for the Redshift Wrangler. Yeah. But for like the newsletter, what's the best place for people to interact with you? So
that's a great idea. And let me show that again, and I will share in the comments, and I hope this will be a clickable link when it goes to you.
Generally they are if they're short enough.
Yeah, if they don't break. Yeah. Did you have another place to tell people about this, or is this the best place to look for?
I say you can find everything about our project on our website. That when you navigate to the talk boards within Zooniverse, that's where I'm sharing all of our newsletters and updates. And we do also have an email list that our newsletter goes out to.
Oh, cool.
You can find us also on our social media. And I think we have a YouTube here, and then we have Twitter and a Facebook page. But all of the information kind of goes out to all of these different places. So typically, if you follow the Zooniverse page, you'll see everything you need to see. But I can also get a link to sign up for our email newsletter. And if email is your preferred method of communication, as it is for me, that I get those notifications easier, then that's also somewhere you can hear about anything that ever happened with Redshift Wrangler.
Sounds good.
Yeah. If you want to go ahead and put it, there's a private chat within this platform. I can. Yep, there it is. I'll grab it and I'll add it as well. Let's see. Yep, there we go. Copy, paste, and that should work as a clickable link too. It looks like.
Yep. So
there you go, folks. Great way to get more involved. Yeah, you might have to register to leave my little bio.
Well, if you don't register, they won't know who the bio is for.
That's true.
Exactly.
That's true. All right, so we're going to continue to watch for some comments, and we got a couple little things to go here still. Sadie, if you don't mind sticking around, why don't you go ahead with the...
Okay, some stellar events this week, October 4th through October 11th. It's the beginning of the month, so go to skymaps.com to get your free 2-page star chart.
Skymaps.com. I'm going to skip that part. Go ahead.
Okay, October 5th, Venus and the Moon are in conjunction. Venus is 3 degrees north of the Moon. October 7th, Antares is 0.2 degrees north of the Moon. It's really close. They don't say anything about an occultation, so...
There must be. Maybe somebody in the audience knows.
Maybe it's more likely to occult them if it's south of the Moon, because
I
always see the occultation notices when something's to the south of the
Got
Moon.
it. But, yeah, I don't know. We reference a couple places. One is the Farmer's Almanac, the Old Farmer's Almanac, this one. And then Jeff's been looking at a calendar. So we're trying to put together some information that you can look for this week. Go ahead.
October 9th, I love how they say this. The moon runs low. Sounds like it needs a recharge. And Jupiter appears stationary. And the Draconid meteor showers peak. And the best time to observe the Draconids is late evening. And the peak rate is predicted to be 6 per hour.
Yeah, weirdly, this one doesn't give you like a range.
Yeah.
Usually you can see meteor shower in a range of dates,
right.
But they have a peak date too.
Right. The 6 per hour isn't great. It's like 1 every 10 minutes. So
yes. 1 a minute is hard to do.
There are some that have a higher rate. The source of the meteoroids is the Giacobini-Zinner.
Yep, that's it.
Comet. Yes.
Yeah.
That's the word that went away on me.
Okay.
While you may see meteors in other places, they radiate from Draco for this one. Yeah. October 10th is the first quarter moon. October 11th is Pluto and the Moon in conjunction. Oh, Pluto and the Moon are in conjunction, and Pluto appears stationary. Not that anyone's going to see Pluto. And Yom Kippur begins at sundown. October 11th also is our Friday night show, and we will review. Got to stick around to find out because Pam didn't tell me. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel.
What inspires you the most for this week? And Daniel has a comment. Comment is coming back around October 12th. Okay. Yep. And when you say coming back, is that because it's a Southern Hemisphere thing kind of thing? Sometimes you can see them better from one or the other. Thanks. Thank you for that, Daniel. Appreciate that. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, and Sadie, let the people know. We would love to have them come on our show. We would love to share our life. Join us again next Friday, October the 11th. We're going to review some what I call next generation space companies, space travel companies. And these aren't kind of the Vanguard folks, the Boeings and the really big ones now, but yeah, some of the newer ones, and maybe what they can do for you. So that kind of thing. Anyway, thanks so much for being here, folks. That was Daniel and and Dawn. Thanks for joining us, Sadie. Yes.
Thank you.
Scott
was here. And Simply
Janie.
1V. I don't know if Simply 1V has another name. Janie was here. And also Cliff made it.
Yeah.
Glad you could join us, folks. Really appreciate that. Oh, did we get another one?
Oh, that's interesting.
10th anniversary of the nice. Okay. Dr. Britt. All right. Now we know. Okay. Anything else from you, Sadie?
I think that's all. I'm such a fan of your platform. Thanks for letting me come and chat today.
Thank
you, Sadie.
We really enjoyed that. We've been hoping to get somebody from any of the projects to come and talk to us. So, anything else from you?
No, I've gotten enough trouble.
You have? Okay.
Yes, I'm always happy to chat about this stuff. If anyone is interested in knowing more, I'm always open to answering questions or talking about Redshift Wrangler. I'm mostly found on Redshift Wrangler, but you can find me at any of the platforms I've mentioned.
Yeah, I didn't even know there was a Facebook page until I got an email, and I said, "Oh, they shared your video," and I'm like, "They did?" I was so excited.
It was so good to find all of your content about Redshift Wrangler. It was awesome.
Yeah. We really enjoy talking about them and encouraging people to participate, and we have no idea if they do, but
yeah. And quite frankly, I've only found one real stinker, and I did talk about it.
Which one was that? I don't even remember.
I forget, but it was so hard to do that. It was so hard to figure out what they wanted, and then to do it, that it was just really hard.
Now I can tell them they can go talk to Sadie.
Sadie knows how to do it.
Sadie knows how to do it. Exactly. Oh, we got a couple more comments. Happy moon, Mr. Cliff. Happy day, Cliff. All right. Thanks so much, folks. You have a great week.
Yeah.
And we'll see you later. Hopefully we'll get Sadie back too someday.
Yep.
Good night.